we have removing duplicates from sorted array. So we have a array of numbers sorted in decreasing order. So now we have to remove the duplicates, and this is an important condition in place. So the duplicate removal should be in place. That means the relative order of the element should be kept same, and what we have to return is the number of unique elements. So this is just describing like what will be the size of nums, and whatever we are returning the number of unique elements, so that will be k. So let's see the example. So nums is 112. So we need to find the unique elements and remove the duplicate elements. So we have two ones, so will have 1 and 2, and this can be empty, or like it doesn't really matter since we are outputting it as 2. uh, See, it does not matter what you leave beyond the return case, so it can be empty or anything. So yeah, there is another example which will be again similar, since we have 0, 1, 2, 3, 4. So these 4 elements, and then this can be anything, doesn't matter. What we have to return is output is 5, and in nums array itself we'll maintain the relative order, and just change the first 5 elements to the unique elements. So there are two approaches which we can see this constraints. So the constraints, the length of the array can be 3 into 10 to the power 4, and the numbers can be minus 100 to 100, and it's increasing, not decreasing order. So I have these two coded. So first let's see this option, which is basically what I wrote initially. So let's consider this array. So we have two pointers I and j, and we see if these are same, then we just like increase the second pointer j. So if these two are different, then we increase the I pointer to this position, and swipe I and j, and that's how we can do it. Maybe with a bigger example it can be more clear. So what we'll be doing is we have I at pointing to 0 and j pointing to 1. So we check these are same, so we skip and make j to this one, point to 1. So now we check that 0 and 1 are different, so we can just swap this one with this 0, basically the next element to the I, the current index. So we swap 0 and 1, and then I becomes this, which is pointing to 1, and j becomes this. So it's now again it's same, so we skip. Now again same, it's skip. Now we move to 2. So 2 and 1, which is here, is different, so we swap this item with this. So that's how we'll achieve the 0, 1, 2, 3, 4. So that's what it is coded here. We initialize I0 J1, and also since we need to return the answer, which will be the number of unique elements, so we initialize answer is equal to 1. Since we already know there has to be some unique element, so we start with 1, and yeah. So we iterate through the complete array. So what we check is if the numbers are different, then we swap with the next element to the current element and the jth pointer, and we increase the answer count, or the number of basically unique elements count, and we also increase j plus plus, and that's how we return. So I basically found another unique solution, which is just two liner. So what we do here is we find the unique elements from beginning to end. And what this returns is the basic. Okay, let me show you some examples. So what this unique part will do. So what it does is, let's say we have something like this. So what it will do is, unique elements will return is 1, 2, 3, 4, and the pointer will be so our iterator will be pointing to the next element to this 4. So what we do is we erase uh, from pointer after 4 till the end, and that's how we get the numbers 1, 2, 3, 4. And yeah, basically unique also arranges all this. So it will be basically 4, and then 1, 1, 2, 2, 1, 2, 3, 4, and 3, 3, 3, 4, 4, 4. So this will be the array. And now we need to just erase these last elements, and returns as a size, since we have erased all the extra elements. So yeah, both of the things work. Maybe first I'll show that first code works. So yeah, it's accepted. You can see the more details here. So runtime is 4 millisecond. Now we can again run this and just comment out the other solution. Anyways, doesn't matter, and we do submit, and it says accepted. And let's see the runtime. So here the runtime is little more. So what we are doing here is just using the C++ library to find the unique elements. So the time complexity must be higher. So this is like the fastest solution. This is like more concise solution, but it runs with more time complexity. Yeah, that's all, folks. See you in the next video. Basically, I'm trying to solve all the easy questions needed for the interview. So basically there are around 5, 50 or 60 easy questions. Then I'll move on to medium, again 50, 60 questions, and then maybe hard 50, 60 questions, which is around like 150 to 160 questions in total, to ace the top interview question and like ace your preparation for the interview. That's all, folks. See you in the next video.